I am Nina Saveta. I will present you today's SPM bench. It's a scalable, schema-aware instance matching benchmark that is based on the semantic publishing benchmark. Primarily, we have many open and social data. Everyone is a publicist. Everyone can publish his own data in a way that is convenient for him or his application. We also have errors due to data acquisitions. For example, in order to process scientific data, we may have different expression of the same data. From the data, as time goes by, the data have evolution, so they change. And from the data integration by itself, we may introduce errors in our data. So there are so many instance matching algorithms in the previous years that we would need to compare these to assess their performance and also to push them to get better. So we need the benchmark, the instance matching benchmarks. That's what we implemented. We implemented SPM Bench. SPM Bench, as we said, is based on semantic publishing benchmark for LDBC. It's a synthetic benchmark. It has value-based, structure-based, and semantic-aware transformation, as well as combination of those in a simple and more complex way. Its generator is deterministic and scalable in order of billion triples, is the version 1 of a semantic publishing benchmark. And we also have a weighted gold standard in order to help the systems improve themselves and debug them. In order to have a benchmark, it must satisfy 4 conditions. We have to have the dataset, the source and target dataset, that we will give to the instance matching systems in order to link them. We have the gold standard, that are the correct answer sheet, in order to see the performance of the systems. We need to have test cases for different, in order to see different, to check different tests, and we have the metrics that help us to assess the soundness of the systems. Here is the SPM Bench model. Through the configuration file, the instance matching system can have the data generation parameters and data transformation parameters. When the data generation is done in parallel with the data transformation, the matcher keeps in details the transformation that are applied in the instance, in target instance, in the source instance, in order to produce the target instance. As we said, we have five categories of transformations. We have the value transformations that are mainly typographical errors that refers to the use of different formats in data type properties. We use swings transformation, and we also enrich them. We add multilinguality, the stemming of the words, antonyms, abbreviation of country names, and there are also blank car addition, random car addition, etc. We have the structural transformations that are changes that occur to the properties, that are properties addition and deletion, and property aggregation and extraction. The most important category are the semantic aware transformations. SPM Bench is the first that introduces semantic aware transformations that go beyond the standard RDFS constructs. We have instance equality and inequality. All same as and different from. We have equivalence of class and properties, disjointness of class and properties, RDFS hierarchies that are subclasses and subproperties, property constraints, functional and inverse functional property, and complex class definition, union of and intersection of. We have a combination of those in a simple way. For every instance, we apply a different category in every triple, and complex combination of those. In every triple, we apply more than one transformation. We wanted to have a weighted and scalable benchmark. So we saw that in order to do that, we need a lot of time and resources, so we added the sampling phase. In this phase, the user is able to define the number of files we are going to use in order to calculate the weight or else the difficulty of the test cases. But in parallel, we calculate the proper number of the files using Jensen-Shannon divergence. And we achieved the phase of the calculation of the weight. That is, we used RESCOL as a multi-relational learning approach. With RESCOL, we are able to define how much information we lost in order to produce the target instance from the source instance. So we now have a weighted gold standard file. In fact, we have two gold standards, a detailed one that has the URIs that are matched, the instances that are matched, with the details of transformations that are applied to it, and the final one that has only the instances that are matched with the final weight. We did scalability experiments for data set up to 500 million triples and transformations up to 25%. The results were says that the data generation along with the data transformation is linear to the size of triples. The transformation overhead is negligible for value structure-based, semantics aware and simple combination, and is 1 magnitude higher on complex combinations because we do this category in a more manual way. So you can see here. We checked the applicability of SPIN bench using LogMap. LogMap is a continuously evolving system. So we run we run LogMap for every category of our transformations. For percentages up to 25% again. And we saw that SPIN bench is able to define the weak and strong points of an instance matching system. Concluding, SPIN bench has schema-aware variations that go beyond the RDFS construct, the standard RDFS constructs, has complex class definition, property constraints, has combination of these transformations, uses sampling and in order to generate and calculate the weights. It has a weighted gold standard in order to help the system debug. As regards our future works, we are going to be used as one of the benchmarks in OI 2015. We are going to be at DAB 2015. And we are currently working in a domain-independent instance matching test generator. The user will be able to give any RDF dataset and ontology, and we will create the target and the target dataset and the gold standard file. And we are working also on defining the more sophisticated metrics that will take into account the weights that we calculated in tandem with the standard precision recall metrics. Thank you.
What systems could currently compete in SPIN bench? So LogMap is one of them.
LogMap is one of them, yes. We had difficulties in finding systems that can support those semantic aware transformations, but we are trying to push them to support because you can't have dataset only with subclasses and subproperties. So we will run SIME, that is a new version of LIMES, but is not done yet. It's not the final version. And we are trying an instance matching system that we have in Forth. It's called Auto. But we had difficulties in finding systems that support schema-aware transformations. Most of them support only value and structure.
Right. Maybe a question for Naso. So, for these kinds of tasks, are there commercial products available?
Well, I think it's very.
commercial context, it's relatively hard to impose these kind of constraints and to use them for what I would call identity resolution. So, okay, let me put it in a different way. You have to start with fairly clean data.
Yes.
The different data sets that you're trying to merge should be relatively clean to allow you to do this type of matching.
Yes.
Which sometimes is the case with well-maintained internal data sets, or if you're buying data from, I don't know, Factiva or FactSet or Dun & Bradstreet, whoever. But in most of the cases that we've seen currently, people start off with less perfect data sets, and using this would be harder.
Yes, that's the reason that we implemented the newest version that only has the generation of the target data set and the gold standard, and we allow the user to give us the data set and the ontologies.
So, yes, it is usable for under these circumstances, but for less clean data, you need the sort of infrastructure that is used, for instance, for the generation of DBpedia and yeah, they're just different tasks. I hope one day soon we
Yeah,
have
me
more
too.
job for this type of benchmark.
Okay, thanks, Nina.
Thank you.
So